All right, so for today's notes, we are going to do page 11 on acid and base strength, so a little review of what you did from the POGIL. And then there's some practice on page 12, just modeling strong acids and weak acids and strong, and how that relates to concentration. So strong acids and strong bases, as you have learned, completely dissociate in water. Okay, so remember, this has nothing to do with concentration. So you can have an acid that's a weak acid that has a very high concentration. Okay, so what's between a strong acid and a weak acid? Strong acids are going to readily donate their protons. Okay, so a strong acid, all of the acid molecules are going to break apart into ions or in solution, which means that they are going to dissociate completely. Okay. A strong acid is a strong electrolyte because it completely breaks down into the ion that forms it in water and will conduct electricity. This process of it breaking down in water is called ionization. Okay, so it's going to completely break down or dissociate, which makes it a strong electrolyte. The protons that are donated to water, so those protons are donated to water, and a weak base is formed. So we have that conjugate base that's formed, it's weak. So these are going to form weak conjugate bases. Okay, so these do not readily accept a proton to go back in the opposite direction. So strong bases kind of work the same way, but this time we're talking about how they will readily gain protons. So these readily accept protons. So with a strong base, all of the molecules are going to dissociate or gain a proton. Okay, so this is called becoming protonated. So if we say that, oh, that's an N. If we say that a molecule has been protonated, that means it's gained a hydrogen ion. So these are going to form weak conjugate acids. So they, once they become protonated, they don't readily donate that hydrogen ion back. So in water, weak acids and weak bases produce only a few ions when equilibrium is reached. So keep in mind that just because an acid or base is considered weak does not mean that it's not dangerous. You have to really look at the ions that are involved. Those really dangerous acids and bases produce ions that are still very reactive, and that reactivity of those ions is what causes it to be so corrosive. So for example, hydrofluoric acid is a weak acid. It does not readily dissociate. So if we write the dissociation reaction, so if this just forms hydrogen ions and fluoride ions, so it doesn't form a lot of hydrogen ions in solution, which also means it doesn't form very many fluoride ions, but the few fluoride that it does produce are highly reactive, which is what makes it very dangerous. So we'll get an opportunity to watch a light bulb in hydrofluoric acid with a really fun video. After you've watched that video, go ahead on to the next page and you're going to do some modeling on the difference between strong and weak acids. And then, so over here it says WRS, so that's weak or strong. And then also we're going to look at concentrated versus diluted. So where concentrated means that you have a lot, like many molecules per volume. Diluted means that you have fewer molecules per volume. And then you can write a little example like one molar versus zero point 0.1 molar and give examples of weak and strong acids. Okay. Of course, if you have any questions, just let me know.